Decomposition-based, call graph-based, path-based integration, presented by Varun. Decomposition-based integration. Decomposition-based integration in software testing refers to a testing approach where the system is divided into smaller components and each component is tested independently before integrated into the larger system. The approach is also known as the incremental integration testing or bottom-up integration testing. In decomposition-based integration, the test process starts with the lower-level components such as individual functions or modules and gradually integrates them into higher-level components and subsystems. Each component is tested into isolation using appropriate test cases to ensure its correctness and functionalities. The main idea behind the decomposition-based integration is to identify and fix the defect and at the component level before integrating them into a larger system. By testing each component independently, it becomes easier to pinpoint and isolate issues, making debugging and troubleshooting more manageable. The integration process typically follows a predefined sequence, starting with the integration or most basic components and gradually moving towards higher level components. This allows for the step-by-step construction of the system, verifying the integration of components at each stage. Advantage: early defect detection and enhanced modularity. Incremental development, localization of issues, parallel development. Disadvantages: integration challenges, limited system level testing. Mocking and stopping. During the integration of higher level components, the availability of lower level components may be limited. To overcome this, developers may need to use mocking and stopping techniques to simulate the behavior of missing components. Increased effort. Testing each component individually requires additional effort as it involves setting up the test environments, test data, and maintaining separate test cases for each component. Call graph based integration in software testing is a technique used to analyze the interaction and dependencies between the different components or modules of a software system. It helps in identifying potential issues and ensuring that the integration of these components is functional correctly. A call graph represents the calling relationship between different functions of methods within a software system. It shows how functions or methods are connected and how they interact with each other during a program execution. By analyzing the call graph, testers can understand the flow of control and data between different components, which is crucial for integration testing. Here is an overview of how call graph based integration testing works. Static analysis. The first step is to generate a call graph by performing static analysis on the source code or compiled binaries. Static analysis tool can parse the code and build a representation of programs, control flow, and function calls. Identifying the entry points. Once the call graph is generated, testers identify the entry points of or interfaces through which the components interact with each other. These entry points could be function calls, method invocations, or message passing between the modules. Define test scenarios. Define test scenarios based on the identifier, entry points, and the expected behavior of the components. These scenarios simulate different interaction between the components to ensure they work correctly together. Test execution. Test cases are executed by providing input to the entry point and observing the output or behavior of the system. The call graph is used to track the flow of control data between the component during the execution of each test case. Analyze results. Test results are analyzed to detect any failures, error, or unexpected behavior. Testers examine the call graph to identify any missing or incorrect interaction between the components. They may also look for performance bottlenecks or resource utilization issues based on the call graph analysis. Benefits: comprehensive coverage. By analyzing the call graph, testers can ensure that all relevant components and their interaction are included in the integration testing process. This helps in achieving the comprehensive coverage and reducing the risk of missing critical scenarios. Early issue detection. Call graph based analysis can identify potential issues such as missing dependencies or incorrect interactions before the actual integration test phases. This allows for the early detection and resource of problem solving. time and effort in the later stages of development. Test prioritization. Analyzing the call graph helps in identifying high risk or critical components that require more testing focus. Testers can prioritize their efforts based on the complexity and importance of the interaction between the different components. Regression testing. Call graph based integration testing can be valuable during regression testing when changes are made to the software system by comparing the new call graph with the previous one. Tester can identify any unintended changes in the component interactions and ensure that existing functionality remains intact. Path-based integration is in software testing refer to testing technique that focuses on the testing that various execution paths through a software system. It involves identifying and testing different combination of paths or sequences of instructions to ensure that the software behaves as expected under different scenarios. Path-based integration testing is typically performed during the integration phases of software development lifecycle, where individual components or modules are combined and tested together to ensure their proper interaction and functioning as a whole system. Here are some key points to understand about the path-based integration testing. Integration testing is a level of testing that verifies the interaction between the different components or modules within a software system. It ensures that these components work together as expected and the data flow correctly between them. Path-based integration testing is a specific approach with the broader context of integration testing. Path and execution of flows. In a software system, there are multiple paths or execution flows that can be taken based on the different inputs, condition, or user interaction. Each path represents a specific combination of instruction or code branches executed within the system. Path-based integration testing aims to test these paths to uncover any defects or issues that may arise from their interaction. Path identification. To perform path-based integration testing, testing needs to be identify the various paths or execution flow within the software system. This can be achieved through techniques such as static code analysis, control flow analysis, or by analyzing the system specification and requirements. Test case design. Once the paths are identified, test cases are designed to cover the different combination of paths. Test cases may be designed to follow specific paths or to traverse multiple paths depending on the complexity of the system. The goal is to achieve maximum coverage of the software test system by testing different execution flows. Test execution and validation. Test case designed for the path-based integration testing are executed and the system behavior is observed and validated against the expected outcome. This process helps identifying any deviation from the expected behavior and ensure that the software system function correctly under different scenarios and combination. Test coverage. Path-based integration testing aims to achieve path coverage which measures the extent to which the software system execution paths are exercised during the testing. The goal is to ensure that the critical paths, boundary condition, and error handling paths are thoroughly tested to minimize the risk of defects. Tools and automation. Various tools and techniques can assist in performing path-based integration testing. Static analysis tools, code coverage tools, and test case generation tools can help identifying and automate the test of different paths within the software test system. Thank you.